this lesson is on the altitude of a triangle. The altitude of any geometric shape is its height. So we will be trying to determine information about the altitude of a triangle. In this case, we have triangle ABC, and the altitude can be determined from any of the three vertices. I can determine it from vertex A, vertex B, or vertex C. The altitude is essentially the shortest distance from a point to a line. So if I was working from vertex A, I would want to find the line that goes from vertex A and is perpendicular to the side opposite vertex A, which is side BC. And so what we'll do now is we will look at, first of all, the equation of the altitude. So the altitude will look something like this. So it will be the line that is from vertex A and perpendicular to side BC. So if I wanted to determine the equation of this line, there are two pieces of information that I will need. I will need the slope and the y-intercept. When I look at this line, I won't be able to determine what the slope is because I don't have 2 points, and I'm not 100% sure what this point will be, or even if the line that I drew is in fact perpendicular. So what I will have to do, if I know this line segment here and I have 2 points, I can use that information to calculate the slope of this line segment, and then I know that if this line segment is perpendicular to it, then their slopes are negative reciprocals of one another. So I'm going to start this by calculating the slope of line segment BC. So the slope, choose my pen tool. The slope of line segment BC, we know that is y2 minus y1, that's a minus, over x2 minus x1. And I'm going to label my points accordingly. So y2, y1, x2, y2. And I'm doing that to make sure that I am consistent when I am substituting the information into my equation. So this is equal to y2 is 1, and I am subtracting minus 2, so it's 1 minus minus 2, and x2 is 5, and I'm going to subtract minus 1. So I have 5 minus minus 1, so that's equal to 1 minus minus 2 is really 1 plus 2, which is 3. And 5 minus minus 1 is really 5 plus 1, which is 6. And so my slope is not 3 over 2, sorry, it is 1/2. So I have a slope of 1/2. And if I look at my line here of BC, I would expect it to have a positive slope, because it goes up and to the right, and if I could calculate the slope just by using rise and run, and if I notice here, my run is 2 and my rise is 1, so 1, 2, over 2, up 1, over 2, up 1, over 2, up 1, and that makes sense. All right, so we know the slope of line segment BC, so now I am going to use this slope to find the slope of my altitude. And we know that slopes of perpendicular lines are negative reciprocals of one another. So my slope of my altitude, I'm just going to do a subscript ALT, is equal to, I'm going to change the sign. The original slope is positive, so this one's negative, and I'm going to take the reciprocal of 1/2, which gives me -2/1, and that is equal to -2. So I know the slope of this line here is -2. So now what I need to do is determine the y-intercept. And the y-intercept can be determined in a couple of different ways. The first way is to, we can use the graph. So if I know that I have to start from point A and I have a slope of -2/1, I go down to 1, 2/1, and that gets me right here. And so this here, the point 0, 2 will be my y-intercept. So I can write my equation of my line. So is y equals -2x plus 2, because I've got my y-intercept from the graph. Sometimes it isn't as obvious as that, because we could be dealing with a point that's between, say, 2 and 3. So what I'm going to do on the next slide is I am going to show you how to calculate the y-intercept algebraically. So we know that we calculated the slope of the altitude as -2, and we know the equation of the altitude must be in the form of y equals mx plus b. So I know my slope is -2, and now I want to determine my y-intercept algebraically. Since this line, the altitude goes through the point -1, 4, I'm going to substitute -1, 4 into x and y of my equation to solve for the y-intercept. So I have 4 equals -2 times -1 plus b. I have 4 equals -2 times -1 is 2. I'm going to rearrange to isolate for b, so I have 4 minus 2, because I'm subtracting 2 from both sides. 2 minus 2 is 0. So that leaves me with b, and I have 2 is equal to b. And as we said earlier, if we look at the slope, that makes sense. So we have y equals -2x plus 2. So this here is my equation of the altitude. So what we're going to do now is we are going to look at, well, we've got the equation of the altitude, but I actually want to find what the altitude really is. What is this length, or what is this height? So in order to determine the height, we are going to need to know what this point here is. I'm going to just label that D. So in order to find out what point D is, because it's not exact, we can't figure that out just by looking at the graph, we are going to have to find the point of intersection between this line segment here and this line segment here. And I'm going to do that on a new slide. So in order to determine what point D is, we need to find the point of intersection again between the altitude, or the equation of the line representing the altitude, and line segment BC. So two things that we need for the equation of a line are the slope and the y-intercept. We have the slope, but we don't have the y-intercept, and we look here at the graph, and that's not something that's easily picked out on the graph. So we have to substitute in one of the 2 points on the line to determine what the y-intercept is. So again, trying to be consistent with my colors here. The equation of a line, y equals mx plus b. We need the slope and the y-intercept. We have the slope. Now I'm going to substitute in one of the 2 points to find out what b is. I'm choosing -1, -2 because it's on the left-hand side of the graph. So I have -2 equals 1/2 times -1 plus b. So I have -2 equals -1/2 plus b. In order to isolate for b, I will need to add 1/2 to both sides. So -2 plus 1/2 equals b, because -1/2 plus 1/2 is 0. Now in order to add these two, I need a common denominator. So this will become -4/2 plus 1/2 is b. So that's -3/2 is b. So the equation of BC is y equals 1/2 x minus 3/2. And if I look at my graph, that makes sense. This line here isn't perfect, and so that would make sense. It's in that approximate area. So I now have my two equations. I have my equation of BC. I have my equation of my altitude. Now I need to solve the linear system in order to determine D, which is the point of intersection. I'm now going to solve this linear system. So equation 1 is the for line segment BC, and equation 2 is for the altitude. So I'm going to solve this by substituting equation 1 into equation 2. I have 1/2 x minus 3/2 equals -2x plus 2. So what I'm going to do is rearrange this so that all of my terms with a variable in it are on the left-hand side, and all of my constants will be on the right-hand side. It doesn't honestly matter which side you choose. I'm just choosing the left-hand side just because. So I'm going to do a couple of steps here at the same time. I'm going to add 2x to both sides to get rid of the -2x, and I'm also going to add 3/2 to both sides in order to get rid of the 3/2 on this side. So I have 1/2 x plus 2x equals 2 plus 3/2. So I will need common denominators in order to add these terms up. So we need a common denominator of 2. So I have 1/2 x plus 4/2 x equals 4/2 plus 3/2. So then I have, I'm actually just going to come right here. I have 5/2 x is equal to 7/2. And so now I'm going to multiply both sides by 2 in order to get rid of the 2 in the denominator here. So I have 5x equals 14 over 2, which is 7. Now I'm going to divide both sides by 5, so I have x equals 7 over 5. It's not a very good 5. Seven over 5. There we go. So I now know what x is. I will need to find y by substituting x equals 7 over 5 into one of the two equations. I'm going to choose equation 2. So that means that I have y equals, my slope is -2 times x, which is 7 over 5, plus 2. So I have y equals -14 over 5 plus 2. Now I'm going to need a common denominator to add these. So -14 over 5 plus 10 over 5. And that will give me -14 plus 10 is -4 over 5. And again, I'm having a hard time with my 5's down there. So I'm just going to fix this to make it a little neater. -4 over 5. All right, so what I have found here is that I have the coordinates here are 7 over 5 and -4 over 5. And we're not 100% sure here because this is just a quick sketch. And so I can't really verify on this diagram. So what I need to do is take these coordinates and substitute them into equation 1 to check to see if they satisfy the equation. So I am going to do that on the next slide. So now we're going to check to see if if the point 7, 5, -4, 5 satisfies the equation or equation number 1, which is BC. So we have y equals 1/2 x minus 3 over 2. So we're going to check to see if this point satisfies that equation. So I have -4 over 5 equals 1/2 times 7 over 5 minus 3 over 2. So I have -4 over 5 equals 7 over 10 minus 3/2. So I have -4 over 5 equals, I need to have common denominators. So I have 7 over 10 minus, I have to multiply everything by 5. So this is -15 over 10. And so -4 over 5 equals 7 minus 15 is -8 over 10. And when I simplify that, -4 over 5 equals -4 over 5. So my left-hand side equals my right-hand side. So this is quite a bit of work. So we know that this point here, D, is 7 over 5 minus 4 over 5. And we verified that by substituting back into equation 1. So we now have all of this information. We know what point A is -1, 4, and point D is 7/5 and -4/5. So therefore, we can use this to calculate the distance or the actual height or the length of that line segment. And we'll do that on the next slide. All right, so if you remember, the distance formula or the length of a line segment is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And I will need to substitute in my 2 points. And I'm going to label my points x1, y1 and x2, y2. It doesn't really matter which one you choose, as long as you are consistent. So this is x2, y2. So the distance is equal to the square root of 7 over 5 minus 1, and that's all squared. And y2 is minus 4 over 5 minus 4 all squared. And that is equal to, I need common denominators of 5. So 7 over 5 minus, and this will be minus 10 over 5 all squared, plus minus 4 over 5 minus, and this is 20 over 5 all squared. So my distance, oh, I forgot the bracket there, is 7 minus 10 is 17 over 5 all squared. And this is minus 4 minus 20 is minus 24 over 5 all squared. So 17 over 5 all squared is 11.56 plus and minus 24 divided by 5 all squared is 23.04. So my distance is the square root of, I'm going to add those two numbers, 34.6. I will take the square root of that, and I have 5.88. So I'm rounding that to 2 decimal places. All right, so so we have worked on determining the equation of the altitude of a triangle. So again, the altitude is just the height. So we determined the equation of this line. And then we actually found the length of this line. And so in order to determine the equation of the line, we know that it is perpendicular to this side and going through this point. And then we had to find, in order to calculate the length, we had to find the point of intersection of this line and this line, and then use that information to finally calculate the distance. So now, if you want, it is your turn. So what I'm going to do is ask you to pause the video and try to determine the equation of the altitude and the length of the altitude from vertex B. So I don't know if that's perpendicular or not. It doesn't look very perpendicular, but it's essentially this line here. And so you'll need to go through the same process as was previously done by finding the slope of line segment AC, using the negative reciprocal slope in order to determine the slope of this line, then use this point here to substitute that into y equals mx plus b to find the y-intercept. So you should pause the video, try it on your own, and then start if you're either stuck or if you want to check your answer. Okay, so I'm going to go fairly quickly through this just because you've already seen an example fully explained. I need to calculate the slope of AC, so x1, y1, x2, y2. My slope of AC is y2 is y2 minus y1 over x2 minus x1. And that is equal to y2 is 1 minus 4 and x2 is 5 minus 1. And this is minus 3 over 5 minus 1 is 6. So I have minus 3 over 6, which is negative 1/2. So if I know that my slope of AC is negative 1/2, the perpendicular slope, so I'm going to do that, is the negative reciprocal. So I will have to change the sign, which will be positive, and it then becomes 2 over 1. And so my slope of my perpendicular line is now 2. Alrighty, so we have the slope. Now we need to find the y-intercept. It is not that obvious based on the graph that we have here, so I will need to substitute in another point, which is -1, -2. Alrighty, so we have y equals mx plus b, which is 2x plus b. I do not know what my y-intercept is, so I will substitute in -1, -2. So -2 equals 2 times -1 plus b. -2 equals -2 plus b. I'm going to come up here. I'm actually going to, make a line here so that we don't get confused as to which calculations go with which. So I have to add 2 to both sides in order to isolate for b. So I have -2 plus 2 equals b, and -2 plus 2 is actually 0, so 0 equals b. So that means, well, that's kind of nice. The slope of the equation of my altitude is y equals, my slope is 2x. There we go. That's my equation of the altitude from vertex B. All right, so we know the equation of the altitude. Now what we want to do is find this point of intersection, and I'm going to label this E so that we can figure out the length. So we will do so in the next slide. So in order to find point E, I will need to know the equation of line segment AC, and so that later on I will solve the linear system to find point E. So I already know the slope of AC. That was determined in the previous question. So my slope of AC is equal to -1/2. Now what I need to do, that doesn't really look very negative. There we go. Now what we need to do is find the y-intercept. So I have y equals -1/2 x plus b. I can use either point A or C to substitute in for x and y to solve for b. It doesn't really matter which one you choose. I'll choose point A. So we have 4 equals -1/2 times -1 plus b. And I have 4 equals 1/2 plus b. I will subtract 1/2 from both sides. So I have 4 minus 1/2 equals b. I need common denominators, so 8/2 minus 1/2 equals b. And I have 7/2 is my y-intercept. So my equation of the line representing line segment AC is y equals negative 1/2 x plus 7 over 2. So now we're going to find the point of intersection between the altitude and the side AC. So I'm going to do that by substitution. I'm going to take equation 1 and substitute that into equation 2. So I will have y equals negative 1/2 times, oops, that is not correct. Sorry, here we go. I will have 2x equals negative 1/2 x plus 7 over 2. I'm going to rearrange this to have all my x terms on one side. 2x plus 1/2 x equals 7 over 2. Common denominators, 4x plus 1/2 x equals 7 over 2. That will give me 5/2 x equals 7 over 2. Multiplying, I'm just going to bring this over here. I will have, multiplying both sides by 2, I have 7 over 2 times 2. Those cancel out. 5x equals 7. Dividing both sides by 5, I have x equals 7 over 5. All right, I know what x is. Now I have to determine what y is. I'm going to substitute that into equation 1. So sub x equals 7 over 5 into 1. And that gives me y equals 2 times 7 over 5, and y equals 14 over 5, which is a little less than 3. And if I look here, the y-coordinate does seem to be a little less than 3, and the x-coordinate is a bit more than 1, and that seems correct too. But what I need to do again is to verify that 7 over 5 and 14 over 5 satisfy equation 2. And I will do that on the next slide. So I'm now going to check to see if 7 over 5 and 14 over 5 satisfy equation 2 by substituting those into in for x and y, and check to see if left-hand side equals right-hand side. So I have 14 over 5 equals negative 1/2 times 7 over 5 plus 7 over 2. So 14 over 5 equals negative 7 over 10 plus 7 over 2. And that is 14 over 5 equals, and I need common denominators, which is 10 equals minus 7 over 10 plus 35 over 10. So 14 over 5 equals minus 7 plus 35 is 28 over 10, 14 over 5. Reducing this is 14 over 5, and I have left-hand side equals right-hand side. So we know that 7 over 5 and 14 over 5 satisfy both equations, and so it is the point of intersection. So last on the list of things to do is to actually determine the distance, or the altitude of the line segment. So we're doing from vertex B, which is, I'm going to switch colors here. So we want the length from vertex B to E. So it's line segment BE. Alrighty, so distance is equal to x2 minus x1 all squared, y2 minus y1 all squared. We know that B is -1, -2. So we have 1 minus 7 over 5 all squared minus 2 minus 14 over 5. That's a 4. It's not a very nice 4, so let's make that look a little nicer. All squared. That is equal to common denominators, which is 5 over 5 minus 7 over 5 all squared plus minus 10 over 5 minus 14 over 5 all squared. And this is equal to minus 2 over 5 all squared plus this is minus 24 over 5 all squared, and that is the square root of let's add those up. Well, first we'll square them. So I have 4 over 25 plus 24 all squared. Oh, hey, this is big. 576 over 25. Something's not looking very right here. Plus 4. And if I take the square root of that, I have 580 divided by 25, and I'm taking the square root of all of that. So divided by 25. Sorry, I'm just doing this on my calculator right now. Oh, it is right. Okay, so this is equal to 4.82. So that means the altitude from vertex B is 4.82 units. So I hope this has helped. I know this is a bit of a long one, but to determine the equation of the altitude as well as the length of the altitude, hopefully that will help you with any of the problems you encounter.